Great. Thank you so much, David. Nice to meet you all. Thank you all for joining. My name is Charles Oxyer, product manager here for Defender for Cloud, joined by fellow product manager Lara Goldstein. And today we are so excited to showcase to you all how to shift your security left with Microsoft Defender for Cloud, allowing you to identify, remediate, and prevent security issues earlier on in your application development lifecycle. Now, before we get into the solution, let's look at some of the problems we want to address through our DevSecOps solution in Defender for Cloud. First, and one of the most meaningful problems we see across the market today is fragmented visibility. Over 54% of enterprises do not integrate any sort of application security testing into their DevOps pipelines. Applications are being built and deployed, and there's no understanding of the security posture of these applications before they reach production. Next, more than half of enterprises are concerned with rogue applications and compute instances. Without the proper security tooling and monitoring in place, developers have free will to deploy their applications and compute instances into all sorts of shadow cloud environments. And without security having any sort of visibility into this, there ends up being a gap in terms of understanding the comprehensive security state across the organization. Next, there's simply a lack of insights. Even when you do integrate the proper security testing in place in your DevOps pipelines, there's a proliferation of the number of vulnerabilities that begin to populate your dashboards, making it incredibly difficult to set the often resource-constrained security team's time aside to remediate against all of these vulnerabilities and prioritize the ones that are most critical and actually exploitable within your environments. Lastly, there's just still so many pervasive silos between your DevOps, your developers, and security teams. In the world of DevSecOps, having close collaboration between developer and security is more important than ever. Traditionally, these teams have always been siloed, oftentimes don't collaborate well together. So we set out to make it as easy as possible for the handoff between security and developer to remediate your application risk as early as possible. Now, Microsoft's Defender for Cloud's DevOps security solution is part of our overall cloud-native application protection platform. This is a comprehensive platform that embeds security and compliance capabilities across every stage of your cloud-native application lifecycle to prevent, detect, and respond to all of the modern threats that attackers are exploiting. As you know, it's much cheaper to remediate security risk earlier on in the development lifecycle. So being able to catch and prevent these vulnerabilities and exploits earlier on in the process will save your company time and money if it reaches production later on in the life cycle. And all of this lives within our other solutions across cloud security posture management, cloud workload protection, cloud infrastructure entitlement management, network security, all enhanced through the power of generative AI. Now, when we look at the DevOps security solution specifically, we see three core pillars for what our product provides. First is your multi-pipeline DevOps security visibility, taking in all the signal across all of the source code management systems and pipelines that your developers are working in and aggregating them into a single dashboard, allowing for simplified visibility of all of the posture assessments across each of your environments. Now, as we know, this can often lead to an increase in noise and signal as static analysis security toolings will oftentimes produce an endless list of findings. Many of them end up being false positives or impacting certain applications that are sandboxed, which is why we also have extensive code to cloud contextualization capabilities, allowing your security teams to prioritize what matters most. Lastly, we want to automate the remediation process with integrated security intelligence, making the handoff from security teams to developers as simplified and seamless as possible. Now, when we look at the unified visibility of our DevOps security posture, there are a few core value areas that I want to touch on. First is the automated discovery. After you create a connector into Defender for Cloud from your DevOps environments, we'll automatically discover all of the repositories and pipelines being used across each of your environment to ensure that there's no more, shadow repositories that are deploying applications that you had no idea that your developers were working in. Next, we work better together with GitHub Advanced Security and GitHub Advanced Security for Azure DevOps, ingesting all of the vulnerability findings from each of these advanced security platforms into Defender for Cloud. So you have a single dashboard to fully understand the security risk within each of these repositories. In addition, we not only scan your application code itself, we scan your entire DevOps environment to ensure all of the configurations and access controls across all of your source code management systems and pipelines are following security best practices. Next, we'll discover all the infrastructure as code templates and identify misconfigurations, no matter if you're using ARM, Bicep, CloudFormation, no matter where you're deploying, we'll be able to identify where you have misconfigurations and help you all prevent these insecure resources from being provisioned from the start. Lastly, we provide security insights through a few different channels. The first being our DevOps Blade, as I mentioned before, providing that single console for you to see all of the DevOps security findings across your environment, as well as built-in and custom workbooks. We understand that for security reporting, there isn't kind of a one-size-fits-all solution. And therefore, through workbooks, we provide almost like a data visualization playground for you to customize all of the data and signal that we bring in to create the reports that you all need to provide that fit the needs of your company. But enough just talking about the value that we provide. Let's get hands-on with the product, and I'll show you exactly how you can start securing your applications earlier on in the development's lifecycle today with Defender for Cloud. Now, when we go into the Defender for Cloud portal, we see the overview page, and the first step will be to create your DevOps connectors into the Defender for Cloud environment. To do this, you want to go into Environment Settings and add a new environment. There's 3 environments that you can add from today: GitHub, Azure DevOps, and GitLab, depending on where your developers are writing and deploying their code. Let's take Azure DevOps as an example. When I begin to create my Azure DevOps connector, I'll see a very familiar process, like if I was creating an AWS or GCP connector for my cloud environments. I enter in a connector name, test, pick a subscription and resource group, and a location for the connector to be created in. After that, I simply need to provide my access token to Azure DevOps in order for the Defender for Cloud service to identify all of the projects and repositories that exist across your organization. Once you authorize the token, you simply review and generate and then create the connector. I already have a connector created, so I'm not going to finish this process, but it's as simple as that. Just by providing us your token and having the necessary permissions from the Azure DevOps side, we'll be able to then auto-discover all of your inventory that exists across each of your organizations. Once the connector is created, you'll be brought to the DevOps Security Blade. This is where we begin aggregating all of the findings that we detect across all of the resources you just onboarded. Immediately after onboarding, we begin assessing the security state of your environment. As I alluded to earlier, we have a lot of checks in place for assessing the access controls and other security configurations of your environment. These include things like the restriction of self-hosted runners, enhancing branch protection rules in your CI/CD pipelines, scoping secret access and variable groups, for example, in Azure DevOps, and many more environment posture management recommendations that we begin detecting and alerting you all on through Defender for Cloud. To see these, if you're in the DevOps blade, you will see a DevOps environment posture management recommendations pane. From there, you can see all the high severity recommendations that you should remediate for these configurations in your environment. You can also click this Learn More button and read about all the different DevOps threat matrix, risk reductions that we do for your environment. Now, beyond just scanning your environment configurations to identify security risk, the next step will be integrating our security tooling CLI into your pipelines for us to begin scanning your application code and binaries for any security risk and reporting these findings back to Defender for Cloud. I'm going to take Azure DevOps as an example and configuring our CLI in ADO, but it's also integrated as a GitHub action as well. So going into Azure DevOps here, I have a sample findings repository that has lots of infrastructure as code files across all of these different template types. It has Docker files, it has Helm charts, it has Kubernetes configurations, all the different multi-cloud templates, all the different ways you all configure and provision your infrastructure. Now I have this example Azure pipelines YAML configuration. What this pipeline is doing is building a sample .NET Docker application through Docker and containerizing it. With the container image, what we can then do through Microsoft Security DevOps, the Defender for Cloud security tooling CLI task, I can have it run open source tooling such as Trivy and Checkoff to both scan the container image that I just built to identify CVEs of the image at build time, as well as any misconfigurations that exist in my infrastructure as code templates through Checkoff. We see in the task here, this is where it's specifying for Trivy and Checkoff, run these tools. We also specify that if there's any high severity vulnerabilities or misconfigurations identified, we want to break the build. This will fail the job to ensure that no high severity misconfigurations or vulnerabilities can make it past the build stage. I'm not going to run this pipeline as I've already ran it before, but essentially what will happen when this pipeline runs, if it identifies any high severity findings, it'll break. And once the pipeline finishes running, all of the security scanning findings from each of these tools are aggregated back into the DevOps security results. And that's when you'll see an aggregated list of your code weaknesses, your infrastructure as code misconfigurations, your secret findings, and the dependency vulnerability results on your third-party components. You can see a breakdown by organization for GitHub, for example, or I can switch to another source code management system and filter down further if I only want to see my Azure DevOps recommendations. Not only will I see the findings for each one, I can see this repository, for example, has 375 code weaknesses identified. I also see the advanced security status, which is whether this repository has GitHub Advanced Security enabled, as well as the pull request status, understanding if I have this Defender for CSPM capability enabled on the repository. Before I go more into pull request annotations and what that capability is, I do want to show another cool part of using the MSDO CLI as part of Azure DevOps. I'm going to take another example here. And the cool part with MSDO is MSDO is essentially a wrapper around a lot of great open source security scanners, ones that we use internally here at Microsoft, and notably ones that we consider best in class. However, we recognize that for a lot of you all, maybe you have different needs, a different set of tools that you need to run in your pipelines. Maybe you're locked in with third-party vendors for certain AppSec tooling. We'll ingest those results into Defender for Cloud as well, and you'll see all those same findings in this aggregated dashboard. So in this example, after my set of tools in MSDO runs, I'm actually running a Microsoft open source tool called Application Inspector. Now, once Application Inspector runs and finds all the different components of my application, I'm actually having the Serif output published into this build artifact. When it's published in this build artifact, Defender for Cloud, thanks to the permissions you all provide to us, can actually read the Serif from these tools as well and display these same results as recommendations in Defender for Cloud. So whether you want to use our open source tooling that we recommend, great. Whether you want to bring your own tooling and see those findings from this central console as well, that works too. All right, moving on. So we've talked about how to onboard, how to consume your security findings from a central console, the different ways that we scan both application code and binaries, as well as your environment configurations. But visibility is great. You get an understanding of the current security posture. The next, though, is how do I actually remediate the issue? And that we have a couple different capabilities for. The first one I'll be showing is pull request annotations. In this same example, when Microsoft Security DevOps runs, it'll produce a series of findings, right? And these will make its way to the security admin for them to look at and triage accordingly. But what if there was a way that we could remediate these quicker and get the information flow between security developer faster? This is where pull request annotations come in. This is an example pull request where I had MSDO run and scan a set of IAC files. On the IAC file itself, it detected a number of misconfigurations that exist. But the cool part here, though, is what we see is Microsoft Defender for Cloud actually annotating the pull request itself. So before a developer will even check in code from their dev branch into a target or main branch, they'll see exactly what the security issue is that was identified through MSDO, as well as all the remediation steps necessary for them to understand what the problem is and how they can actually remediate it. It cuts out all the time between when these findings make its way to the Defender for Cloud portal. A security admin has time to review it, kick off the remediation workflow. This way, developers have visibility immediately. You can even create custom configurations to say like block pull requests from being merged if they have high severity findings, and lots of cool different ways to ensure to use kind of the pull request time as a gating mechanism for any security issues that come up. The other way to kick off a remediation flow, at least from Defender for Cloud, is by going into your repository. You can look at all the recommendations that are affecting the repository. And from there, it's a very similar process to other recommendations and assessments in Defender for Cloud. You can do things like assign ownership, track the last change date, and get kind of the familiar recommendations experience through the Defender for Cloud portal. So I know I've gone through a lot about kind of the visibility, managing your application security posture, all through a dashboard. And while this is great, we can see even in this environment, there's so much security noise. So I'm going to pass things off to Lara now, who's going to go over some of the exciting contextualization capabilities, as well as additional, more advanced remediation capabilities that we've been working on.
Thanks, Charles. All right, let me get my screen shared. Charles, can you see this?
Yep, all good.
Perfect. Okay, so within Defender for Cloud, Charles already showed how we can show you all different sorts of vulnerabilities, from infrastructure as code misconfigurations, open source vulnerabilities, container image vulnerabilities, as well as just general vulnerabilities within the source code management system itself. But this list of vulnerabilities is really hard to sort through unless you have more context. So with Defender for Cloud, we are giving you a way to prioritize these vulnerabilities through code to cloud contextualization. One of the ways we do this is by allowing you to trace risks in runtime back to the source code origin. So with this, we have infrastructure as code mapping. This allows us to ensure consistent, secure, and auditable infrastructure provisioning. customers use the mapping to discover what sort of misconfigurations were found in runtime. Maybe you have a storage account that's exposed to the internet, it contains sensitive data, and if you remediate it during runtime, the issue isn't fully going to go away, because if it is provisioned by an infrastructure as code template, then the next time that infrastructure as code template is deployed, the issue would show up again. So by doing this mapping, you can see the source infrastructure as code file that was used to create this vulnerable runtime resource. So you can then work with your developers to fix the infrastructure as code template within source code before it ever gets redeployed, and you can truly be secure by default with this sort of mechanism. We also have customers that are using our container mapping feature. So this is very similar to infrastructure as code mapping, but this is around bridging the gap between any sort of running applications, running containers, and the Docker files that actually built those containers. And with this, we allow our customers to see all vulnerable running containers that may be in pods that are exposed to the internet, or they're running on nodes that allow for host network that use like the host network. Any sort of misconfiguration that can be present, that'll be detected by our Defender Cloud Security Posture Management offering in Defender for Cloud. And you can see how that container image got to the registry in the first place by identifying the build pipeline that was used to actually build and push that container image. So again, you're able to work with your developers, have them remediate that vulnerability at the source because you can't patch a running container, and ensure that all future deployments are secure. And then lastly, we have a feature called service principal mapping. And this shows how your code CI/CD pipelines can actually access your cloud environments. So typically when customers are working within Azure DevOps or GitHub, they are using service connections that allow them to provision resources in Azure, AWS, Google Cloud. And we're showing how this actually, what those relationships are. So we can tell you if you have an Azure DevOps pipeline that is connecting to Amazon Web Services, and that pipeline is defined in a repository that doesn't have branch protection, which could cause a risk if someone were to get access to that repository. They can then use that pipeline to move laterally into the cloud resources, maybe exfiltrate sensitive data, make changes, change around permissions. They can essentially do anything that the build pipeline would be able to do with the permissions assigned to that build pipeline. Now that we're showing you all of these different sorts of mapping so you can better understand your risk, we're also giving you attack paths. So we have an attack path that lets you know if you have a repository that doesn't have branch protection, it's publicly accessible, and it connects to a cloud environment. We also have attack paths when you have exposed secrets in publicly accessible repositories, because that's something that you truly want to prioritize, get rid of those secrets, rotate them as quickly as possible so that attackers don't come in, find the secret, and then exfiltrate your runtime resources. And while we give this all to you just through the portal and recommendations and attack path analysis, we always know that our customers want flexibility. So we have all of this data within the Cloud Security Explorer and Defender for Cloud, so you can write your own queries to discover the relationships between code and cloud. So let's see what this looks like. First, I'm just going to quickly show you an attack path for an Azure DevOps repository. So in this attack path, we're looking for different sorts of risky combinations. And here we have an Azure DevOps repository that allows for public access and it has a plain text secret. So an attacker can read the secret and use it to connect to assets within the organization if it is an active secret. And we can see that to resolve this attack path, we need to go to the recommendation to resolve the secret scanning findings and understand that there are personal access tokens exposed and storage account keys that are exposed. Moving on for the more code to cloud related features, within Cloud Security Explorer, we can run various different queries. Starting out with infrastructure as code mapping, we're able to see, we can choose storage accounts here. We can look for all of our storage accounts that are exposed to the internet, and they are provisioned by a code repository. So when we run search here, we'll be able to see all of the storage accounts in the organization that have a risk of being exposed to the internet, and they come from an infrastructure as code file. This way, when you click on the information, you can actually see the infrastructure as code template that was used to provision this storage account and work with your developers to remediate that infrastructure as code template and ensuring that that storage account is no longer exposed to the internet. So we can click on this and we are taken to the code repository and the exact infrastructure as code template in question. We also have some query templates to make this a little bit easier for you. So for example, we have a query template here that says, let's look for all container images that are running in production that are pushed by repositories with high severity vulnerabilities. So this query would return all container images that are actively running, they have high severity vulnerabilities, and they were built by a code repository where we would be able to see the exact build pipeline run that actually push that container image and work with the developer to resolve those vulnerabilities. And then moving on, I wanted to show the service principal mapping feature. So here we have, we can search for all of our CI/CD pipelines and code repositories that can authenticate as either an AWS access key or an Azure service principal or a GCP service account. And when we run this query, we'll be able to see how our CI/CD pipelines and code repositories can actually access our Azure resources or AWS or GCP. So here we can see all the different pipelines that actually have permissions to access AWS, Google Cloud, or Azure. And we can continue to add on to this query. So we can say, I want to see if these identities actually have permissions to any sort of resources like storage accounts or virtual machines. And we can also see if the code repositories or CI/CD pipelines have any sort of misconfigurations associated with them. So in this case, I'll look for recommendations where the title is equal to the GitHub repositories allow for forced pushes to the default branch, or the GitHub repositories don't have protection policies for the default branch enabled. So you can continue to expand on this query, make sure it is in the best place possible where it makes sense for your organization, and run the searches and triage those issues accordingly. Moving back into the demo. So with all of the ways that we give you to actually prioritize these vulnerabilities so you can start your remediation, we also need to make it easier for you to remediate. So that brings us to our last pillar of DevOps security, where we're helping you automate remediation with integrated security intelligence. So first, when you do see an issue from Defender for Cloud, you have a couple of different options. You can use Azure Logic Apps for any sort of custom workflow that makes sense for your organization. Maybe that is creating a work item within Azure DevOps or an issue in GitLab or GitHub. Maybe it's sending an email to whoever committed the code. Whatever makes sense, you are able to do through Logic Apps. You can also set up pull request annotations as Charles showed, so you can automatically comment on pull requests to let the developers know that they need to remediate those vulnerabilities. And then lastly, which is most exciting, we can also generate pull requests now using Copilot for Security, which just went into public preview this week. So in the demo that I'm going to show you, I am going to show you the full Copilot for Security story within Defender for Cloud. So you'll be able to see how we help with exploring risk, remediating risk in runtime, and then remediating risk at the source within infrastructure as code templates. Let's go through that. All right, so starting off in Defender for Cloud, we can see all Azure subscriptions, AWS accounts, Google Cloud, any sort of open recommendations we have. We have over 11,000 recommendations, which is way too much for any one person to sort through. So when we're thinking about how do we actually prioritize this risk and how do we actually explore what is truly most important, that's when we can go into our recommendations blade and access our first Copilot capability, which is risk exploration. So we would select Analyze with Copilot, and that'll pop up a window that will allow us to begin to analyze our risks. So we can select, maybe show us our different sorts of issues for publicly exposed resources, resources with sensitive data, whatnot. Here with the publicly exposed resources, Copilot is going to return a list of all of the resources in these recommendations that are actually exposed to the internet to some degree. So we're seeing all of the storage accounts, the virtual machines, the blob containers, the Kubernetes pods that are exposed, and we can leverage what Copilot just sent us to now apply a filter and shorten the list of recommendations that we want to go through if we only want to see what actually has public exposure. Now that we know this, we can then move on to remediate. So there's this recommendation saying management ports should be closed on virtual machines. And with this recommendation, it is a critical risk because there's exposure to the internet and vulnerabilities. We can see the different sorts of attack paths that are present and how this virtual machine can be used to access SQL. So we need to remediate it. So we click on Summarize with Copilot. And Copilot is first just going to give us a description as to what the issue is, why did the management ports need to be closed, what are all of the risk factors. So we can see that the risk factors include exposure to the internet, vulnerabilities, we need to remediate it. So we can ask Copilot, help me remediate this recommendation because it is deemed critical. Copilot will begin to think about it, and when it's done, it will return a script that we would be able to use right within Azure CLI. So we can just pull it up, click run, that would remediate this issue, which is really easy and just a really quick way. But we know we don't always remediate it as security admins, so there also has to be a way to delegate the remediation. So here Copilot is going to actually prepare an email for us that we can show to the resource owner, just send it to them right away, telling them that they need to remediate this issue with clear guidance as to why it's vulnerable, and you send it right then and there. They can access the resource URL and remediate the issue. And this is great. Very easy way to remediate, but we also sometimes want to remediate at the source. So that's why we have the pull request remediation process. So here within the recommendations that Charles showed earlier for DevOps, we have Azure DevOps repositories should have infrastructure as code scanning findings resolved, And as a security professional, I don't know how to fix that. So that's why we have Copilot actually remediate it for us. So Copilot is first going to give us the option to select the actual security finding that we want to remediate. Here we have one that says containers should not run with allowed privilege escalation because anyone that gets access to this container can then exploit privileges and gain permissions to the host machine. So that's why we want Copilot to fix this, because it is a high severity risk. Copilot will return a description as to the pull request that it will create and why it created it, and what it actually changed. So our security professionals can review the details and then submit the pull request. When the pull request is submitted, Copilot will return a link to that pull request. So then we can actually go ahead and review that. So here we have Copilot telling us it was created and linked. We can click on the link here, and opening this up will open up Azure DevOps in just a second. And now we can see the pull request within Azure DevOps, that it was automatically generated on behalf of the security admin. We're letting the developer know exactly what was changed and why it was changed. The developer can go through, they can review the changes by going to the Files tab and seeing exactly what Copilot for Security did add, which in here, it's just ensuring that allow privilege escalation is set to false. So Copilot was able to effectively remediate this issue, and the security admin didn't have to be a professional at coding, infrastructure as code, container deployments to remediate this and save time for their developers. All right, so moving back to our slide deck, that was the demo that we wanted to show, and now I will actually hand it back off to Charles to talk about some better together stories that we have with other Microsoft products.
Great, thank you, Lara. And as we see, there's lots of exciting new developments here in Defender for Cloud and DevOps security, but we do want to comment on what is the better together story with GitHub Advanced Security and GitHub Advanced Security for Azure DevOps, right? With GitHub Advanced Security and GASDO, as I refer to it, they are building kind of proprietary, best-in-class application security tooling for code security through CodeQL, dependencies through Dependabot, secret protection, and developer code remediation integrated directly into their workflows. While these tools are incredible, best in class for all of these purposes, with DevOps security and Defender for Cloud, we want to unify all of your application security posture into a single console. So whether you're using GitHub Advanced Security or any other proprietary tooling, we will take all of those findings in and aggregate them into this single pane of glass. Beyond just code dependency and secret protection, we want to secure your cloud native infrastructure as early on into the development process as possible, doing infrastructure as code security scanning through the power of best-in-class open source to allow you to mitigate any potential misconfiguration before it can impact a production environment. As Lara demoed, we have lots of exciting code to cloud contextualization capabilities, contextualizing all of these application security findings based off the cloud deployment data that we have within Defender for Cloud. And lastly, automated workflows. Lara demoed an incredible one through Copilot for Security, remediating infrastructure as code risks without any sort of knowledge from the security knowledge from the developer side, understanding what they need to do to complete it, simply having to review the code changes for this infrastructure and merge those into their main branch. For a holistic view, our next slide here gives a great capability distribution between what's included with GitHub Advanced Security on GitHub and Azure DevOps, as well as GitLab Ultimate. There you're getting your code scanning, your static analysis findings through CodeQL, as I mentioned, with software composition analysis, doing dependency scanning, secret scanning, and push prevention, ensuring that secrets can't even make their way into a remote repository. For our DevOps security value in Defender for Cloud, it's split across two different plans today. First, your foundational CSPM, the free pillar, meaning our infrastructure is code scanning, our CLI, all of that can be ran, executed for free. Those findings appear in Defender for Cloud with no additional or no cost required. All of the posture visibility, bringing your own tool and those findings into Defender for Cloud. All of that is free, as well as the hardening recommendations, where we go in and assess your DevOps environment for the different configuration settings. All of that is free. Now, if you have Defender for CSPM enabled anywhere within your tenant, is where you created your DevOps security connector. You'll receive all of these capabilities as well at no additional cost, including your container image security, doing the mapping of container images as well, from the image and registry back to the pipeline that first built and pushed the image, the DevOps attack path analysis that Lara demoed earlier, your developer remediation capabilities like pull request annotations for infrastructure as code findings. And lastly, if you have Copilot for security, you have the automated remediation path as well, allowing developers to simply have to review and merge code with no additional effort on their end. Anyway, if you have any questions about the capability distribution, feel free to reach out or post in the chat. Very lastly, I kind of wanted to just show the end-to-end scenario for Defender for Cloud, embodying how Defender for Cloud has evolved into a comprehensive CNAPP platform beyond just CSPM and cloud workload protection capabilities. So let's take a scenario here where I have a public repository with vulnerabilities that I'm using to push then a vulnerable image. That image eventually becomes a VM that's internet exposed and has high severity vulnerabilities, as well as overly permissive permissions to access sensitive data from a storage instance that interacts with a runtime storage environment where files can be uploaded. Here we see every stage from an exploitable repository to runtime contains risk factors that can be exploited by bad actors. With Defender for Cloud's capabilities, from the very start in DevOps security, we can prevent this misconfiguration. As developers are coding and provisioning infrastructure, we can identify that this VM was not properly configured, giving you early insight into this potential downstream vulnerability. With data-aware posture management, we identified that this VM has way too high of permissions for this storage instance with sensitive data. We also see that the VM is internet exposed, increasing the risk factor and contains high severity vulnerabilities. And lastly, with our advanced cloud workload protection, our malware for scanning for storage will ensure that even when this malware infected file is uploaded, it can be alerted, the SOC team can be alerted and can remediate this issue as quickly as possible. So with that, you see how Defender for Cloud is no longer just focusing on production and runtime environments. We're shifting security left, allowing for simplified remediation as early in the application development process as possible. And with that, we'll go into Q&A.
Well, thank you, Charles and Lara. This was a great presentation. You guys were able to rattle the audience. There's lots of questions that came in, and most of them are answered, but we do have some of them that we would like to go over. So, and perhaps more will come in as we speak here. So we have plenty of time for that. Here goes the first one. This is how much dev experience is needed to use Defender for DevOps effectively?
Yeah, really good question. And this is a common question that we get when we're working with our customers. In general, we do target security personas as the people that will be using Defender for Cloud, reviewing the results, and triaging the remediation of the vulnerabilities. Even though they're not the ones remediating it themselves, they're still getting in contact with those developers to remediate it. However, as Charles showed earlier in the presentation during his demo, there are use cases where you do need to configure your pipelines to make sure they're running our Microsoft Security DevOps tools. And for those cases, it is good to work with a developer team or DevOps engineers to make sure the pipelines are properly configured and don't impact the typical daily workflow of developers.
Thank you, Lara. To use Defender for DevOps, do you also need the paid version of Defender for Cloud?
So our Defender CSPM capabilities are our Defender Cloud Security Posture Management capabilities include DevOps security capabilities. We have a range of DevOps capabilities. Some of them are provided for free. Others require Defender Cloud Security Posture Management. And you only need that enabled somewhere in the tenant. So on a Azure subscription or a multi-cloud connector, one of those has to have Defender CSPM enabled, and then you'll benefit from all of the DevOps security capabilities. There's no separate charge for DevOps resources.
Thank you, Lara. And before going to the next question, I see that some of the questions are coming in regarding the plans and upcoming features. So I just wanted to remind the audience that considering that this is a public webinar, we do not disclose what is on our roadmap. So for upcoming features and the roadmap plans, you can sign up for our Microsoft Cloud Security Private Community Program. And the short link for that has been already shared. If you go up at the top, it's aka.ms/join-ccp. Moving on to the next question. Is Defender using Trivy for runtime assessments? And if not, what is the confidence from Trivy detections versus what Defender runtime would detect?
Yeah, I can take this one. So we're not currently using Trivy for runtime container scanning, nor are we using it for registry time scanning. For those, we're using the power of our internal Microsoft solution, Microsoft Defender for Vulnerability Management, and scanning for vulnerabilities that exist in images there. At build time, we are using Trivy today. We obviously, evaluate all the tools available to us, and may make changes over time. But for now, we're kind of leveraging what's best available in open source. In terms of the confidence level, I'm going to go ahead and say that I would be more confident with our first-party Microsoft solution, as always. But it is good to have different scanners, especially at different stages of development, to get a more holistic view, right, of all the vulnerabilities that may exist. One scanner may miss some depending on the database it's using for vulnerabilities that it's looking it up. But ultimately, I would say the confidence levels is higher with MDVM than it is with Trivy, but it is good to still evaluate the vulnerabilities identified by Trivy as part of your holistic vulnerability management process.
Thank you, Charles. Do we need any agent installation for the runtime workload protection?
No, I mean, not for DevOps, anything DevOps related. In general, there are some plans within Defender for Cloud, like Defender for Servers and Defender for Containers, Defender for SQL on virtual machines that do require agents for full protection. But with DevOps security, you don't have to install agents anywhere.
Great. Well, I think that was the last question. There's one asking for some documentation regarding Defender or DevOps with Defender for Azure PaaS service. So we'll leave that open. Hopefully someone, if has a link to that, would appreciate to share. And again, thank you, Lara and Charles, for being our guest today and for sharing this great information with our community. Also, I would like to thank our SMEs who helped us with answering the questions and providing this resourceful information. And also to all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desires to have a say in shaping our strategies, blueprints, and recommendations, then please, we invite you to become part of our security community, because together we think that we can make a global impact. We believe, in fact, that we can make a global impact. So please join us at aka.ms/security community. This is also where you'll be notified about the upcoming webinars such as this one, and talk about Copilot that Lara touched a bit on. We will have a dedicated session for that integration with a Microsoft Defender for Cloud in July 11. So please follow us there. And also, please take a minute to submit your webinar feedback at aka.ms/security webinar feedback. For those of you who may have additional questions on this topic or any other topic for that matter related to the Microsoft Defender for Cloud, please feel free to raise them on our Microsoft Tech Community discussion space. And the short link for that is aka.ms/MDC community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.
Thanks, everyone.